Hello, this is Mr. Wong. This video is going to cover the graphs in motion mechanics chapter 2, and the graphs are the dt graph, vt graph, and at graph. So we are going to learn about how do we convert one from another one and how do we interpret the graph itself. So in this video, you try to draw the graphs like this on your notebook. Starting with the dt graph here, so you need to put down dt over here. Alright, you don't need to draw the value on the xy axis, but you need to put down the label here, vt graph, and lastly at graph here. And when you try to draw it out, you try to draw it in a column so that you can look at the, say for this one, the green line here. Alright, so you can see when the distance are at this point and the velocity are like that, and then the acceleration are like that. Alright, so these are all synchronized. So basically, when you try to convert from the distance time graph to the velocity time graph, what you need to look at is you look at the slope of the distance time graph, and that will be the value of the velocity time graph. Same thing happen for you to convert vt graph into at graph. You also look at the slope, and when you try to look back from, let's say, vt graph back to convert it back to the dt graph, you look at the area. Alright, and same for at converting back to vt graph. Maybe you don't understand what it means right now, but don't worry about that. I'll talk about this very soon. Okay, so let's start with the easy one. Alright, you need to draw this graph by yourself on your notebook. So let's say this is the dt, vt, and at graph. So let's say the dt graph look like a straight line like that. Okay, so for vt graph, what you need to look at is, if you remember, right, you need to look at the slope, right? So for the slope here, you can see this is having a constant slope. Alright, and because the slope is not changing, no matter at this point, or at this point, they are all the same slope, right? And you can see the slope is also positive, right? So for vt graph, what happened is when you try to draw the vt graph, the value of vt graph has also be constant and positive as well. Alright, I'm not going to draw more than that because you can see the time here is stop, the motion stop here. Alright, so same thing happen when you try to draw the at graph. Okay, so try to make the time synchronized when you try to draw it. And so at graph, it will be 0 because once again, if you look at the vt graph, the slope itself, this one is a horizontal line, and for horizontal line the slope is 0. So that's why the value of the line here is always 0 here. Alright, so it should be very easy. Okay, next scenario, let's say right now the dt graph looks like the opposite way. Alright, so this is obviously having a slope which is constant but negative. Right, going downhill is negative. So for, oh sorry, forgot to put down the letter. So for the value here, it should also be, right, again look at the slope, it should also be constant and negative here. So let's say this one. Alright, constant and negative. For at graph, again, since the line here, this one is negative, sorry, is a constant 0 here. So for at graph, it's also 0 here, so just like the one on the left hand side. So same thing for the time here. Alright, so the third case, let me give you a simple case. Maybe this time is also similar to the second one, but you can see a difference here, right? So it's also negative. I'm talking about the slope, remember, I always talk about the slope here. Negative and also constant. So for VT graph is actually exactly the same as the second one, and therefore for AT graph is also the same, because you just look at the slope. So how come it will have such a difference when you are having different VT graph? It's because the starting point here is actually not having any effect for the slope, right? No matter where it starts, it doesn't really affect that much about the slope. So therefore it won't affect the VT graph and it won't affect the AT graph. So that's how it looks like basically for all the cons, like it's either positive or negative for the DT graph, right? So these are all the possible scenarios. So we have done with the straight line one. Let's start with something a bit more difficult, but still let's start with DT graph. So let's say if you got a line like that, a motion like that, you can see this one is a bit more difficult. And if you try to look at the slope, let's say this one, right, that is the slope at this point, and for the slope here, let's say that will be the slope at this point. So you can see the first one and the second one will have a steeper slope, right? Here is steeper for slope. So that means the value here for the velocity will be higher than number one here. And also you can see this is of course non-uniform, non-constant slope, but this time from time 0 to the end is still positive, right? Positive in numbers. So for VT graph, how you draw will be something probably like this instead, alright, or a little bit steeper, sorry, less steep. Alright, it doesn't, just a straight line, right? Anyway, because we are just trying to draw it in scale only, not with exact figure. So this is how it looks like. So you can see you can compare again. So let's say for the steeper slope here, so the slope value is larger, while this one is not that large. So therefore for the value here it will be bigger. Let's say this is 100, and while at this point it is smaller. So let's say this is 25, right, which represent the slope at this point and at this point. So same thing happen again. This time it's easier. VT graph, which is a straight line here, and you try to look at the slope again. This time the slope, for this is also the slope. This time the slope for for VT graph is a constant positive. So you draw a point constant positive here, alright, and that will do. So again, other than going up like that, you can also draw a line which is something like this. Alright, let's say. Once again, you look at the slope. So for slope, of course, originally here, this is slope is 0. And slope at this point is negative, and then the slope at this point is also negative, but this is even larger here. So what happened is for the VT graph, it starts from 0, of course, and it's getting negative and even more negative. So what happened? It will probably be something like this. Again, a straight line here, alright, but going negative here, negative and more negative here. So if you look at the slope here for this one, again it is a constant slope here, alright, but this time it's going downhill again, so it is negative. So what happened in AT graph would be a constant negative value here. Alright, don't forget the origin is always 0 here. It's always 0 here. Okay. So therefore, if you got something which is a combination of the first and the second example here, probably you can build something like this, which is a U shape here. Alright, so what happened is, let me draw it again. Something like this. For DT graph. So what happened is, for VT graph, you can see the slope at the beginning here, it is very, very negative. Alright, and this is less negative here. Of course, at this spot it is 0. At this spot it is slightly positive, and lastly it's going really, really abstract, right? So positive with a large number. So what happened is, in the VT graph is it start from a very negative number and then it will go to 0. So you can try to draw the time dotted line to help yourself. I should get a better point actually. So at that point, this must be 0, and that will be a positive point. So what happened is, probably the VT graph would look like that. Alright, and going same with the second part, because it's getting more and more positive. And for AT graph, you look at the slope here, which is going uphill. Uphill means positive, and this is constant, so constant positive. Alright, so this is how it look like all the time. Remember, this is looking at the slope, and then this is looking at the slope from the previous one, projecting into the value here. Okay, so how about going backward then? In the beginning of the video, we talk about going downward from graph to graph will be looking at the slope, and while going backward, going upward, will be looking at the area. So let's say the velocity time graph is actually a constant line here, so that you can find, or can always find, the area here. So what happened is, for each time interval, we can always try to trace out the amount of area. Right, in the area here, it represents the amount of distance it traveled. So let's say the amount of distance will be like this. Let me use a red line. Will be like this, and similar for the second and also the third one. So what happened is, this is something like this at last. Right, we should probably go beyond the graph. And when you try to think about this again with the slope, it's always compatible. That means if you think about the slope here, is still positive constant, so that you can think about it in this way. So that is how it look like for the area. But I usually prefer to just look at the slope, right? Or let's say if you can have a constant positive line, then of course the slope here should be constant positive. So I usually think about it this way instead of the area. For area, usually how it's used is, let's say you got a VT graph like this, and then you have a V, like have a motion like this, and then what happened is you look at the area here, and from the area in IGCSE, it won't ask you like what exactly happened for every point on DT graph. Like, it will ask you to draw the whole thing, but it will ask you let's say from the time from 0 to the last, what is the distance travel or displacement travel. So you can calculate it by looking at the area, and of course like for this shape, you can try to split it up with, let's say, trapezoid and triangle, and definitely you will find the distance as such, and you can always project it somewhere on the DT graph, but it's hard for you to draw it out unless you try to draw like separate the graph by different segment. Alright, so I'm not going to go too deep into it this time. One more thing about using the area is, by the way, it is also the same for AT graph. So let's say AT graph is having the area, I mean the slope like that. So the area here is also represent the value of the velocity here, which means when you are having velocity time graph during this time, then the velocity will be the value of velocity will be correspond to the area cover here. So of course you may wonder why it will be in this way, like why would they have such a relationship. That's because for you to finding the area of this, you always use 1/2 base times the height, right, to find the area of the triangle. So let's forget about this. This is like just a maths fraction. For base is actually the time, so that's actually this represent the time, while the height is representing a here. Alright, so t times a is actually v. If you remember, v over t will be a. Alright, so that's why the area here represent velocity. Same for let's say if you got a velocity here, the area is also calculated somehow by v times t, right? Maybe 1/2 or something if it is a triangle, and then that will be the displacement, which will be shown on this. But don't worry, I don't think IGCSE will ask you to draw the graph in that detail. Just make sure you know how to know the basic graph, like the previous two slides, like this one or this one. Then that will be really good enough. And for knowing about the area, then you just need to calculate it for a certain time only. You will not be asked about how to draw a graph for these kinds of difficult graphs. One more thing to bear in mind is whenever you use the area to find something backward, alright, no matter it's using VT graph to find ST graph or you use AT graph, area to find the velocity, the area that you are going to do is always the one from the line and cover with the middle axis, which is the x-axis here. So that's why you are going to calculate this triangle and the area of this triangle only, alright, for displacement. So of course this one for displacement it is positive, while this one is negative. And if it is this graph, then this part will be positive and the area for this one will be negative. Alright, if you try to get the area, let's say you try to get the area for this one, then it will be wrong. Alright, so don't try to do it in this way. It will be totally wrong. And for the last one, as you can guess, what happened is will be the area for this one and the area for this part and area for this part. So these three parts, they add together. Of course, these two are positive and this one are negative, so they will cancel out each. I mean, you need to do some minus or plus here, alright, when you really need to calculate it out. But of course, don't worry, this kind of graph will definitely not be in IGCSE physics. I don't think it will appear in IB as well, because this is a curve, right? And for curve you need to use some calculus, differentiation or integration to do that in, like something you learn in A maths. So if you understand the previous pages, you can stop here, but if you still want to know more, you can again look at this very good picture here. You can generalize all the situation here. So let's start with 0 second to the 5th around the 4th second here. So what happened is, if you look at this spot, alright, the slope is increasing, is not uniform, it's not constant, and this is positive. So that's why for the slope, for the value in velocity, it is increasing and this is positive. Alright, and that's why the acceleration, since the slope of velocity time graph of this part is constant and positive, so constant and positive. Second part for this one, this is a straight line, alright, and therefore the velocity will be also constant with a fixed number, alright, and therefore for slope of this is a horizontal line, so the slope of this will be 0, so that's why acceleration graph here should be 0. For the third section here, this is a bit like the one that we did, right, the U, but this is inverted. So what happened is the slope here is really steep, so negative, very negative, it's really positive, right, going up, and then it starts to be less positive, alright, and here is 0, so you can see 0 velocity, the slope is 0 here, and then it's just going down again, so even more downward here. So that's why what happened is the value of velocity is going down, and this spot is 0, alright, same as like corresponding to the time here, and then it will keep going downward, alright, very negative at this point because it's really negative. So that's why if you look at the slope of the VT graph here, the acceleration will also be negative, constant negative, because the slope here is constant negative here. So that's why it's the same in the value of AT graph here. Alright, so I think for this part you can try to understand by yourself. I'm not going to explain anymore. Alright, that's it. Lastly, I strongly encourage you to draw some graph. Let's say what graph? It could be any graph. Let's say VT graph. You try to draw a line and then ask them how do you convert the graph like that. And last advice is, remember, this is a live advice from physics. Don't be A over T.